Hello, for those of you that don't know me, my name is Benjamin Harris, and I'm here to present my Capstone research project today, and my topic is IBM HR Employee Attrition Analytics. And yeah, let's get started. So the objective of my project was to build a predictive classification model that identifies which employees are most likely to leave the company using demographic, job-related, and performance-related variables. The dataset that I used for this analysis is referred to as the IBM HR Analytics Employee Attrition and Performance Dataset, and it can be found in the hyperlink provided on the slide. That will take you to a Kaggle page, actually, where the dataset needed for this analysis can be extracted. A little bit more about the dataset. The file format is CSV, and the sample size of the original dataset was 1,480 rows by 35 columns. After I cleaned it, I still had the same number of rows, but I had 45 columns. I deleted columns with no information gain. I mapped attrition values to binary values, and I one-hot encoded 7 columns. A little bit about the variables within the dataset. So the target variable is attrition, and then I had 44 inputs or variables. These columns include age, rate or income related columns, distance from home, education, marital status columns, and many other columns listed within the bullet points up there. Yeah. So now I'm going to highlight the exploratory data analysis a little bit. The first slide here, we're looking at the target variable distribution. On the left-hand side of the slide, we're looking at a bar chart that just gives you the distribution of attrition values. The yes values, there were approximately 200 to 300 of those, and the no values, there were approximately 1,200 to 1,400 of those. And then to be more precise, approximately 84% of the attrition values were no, and approximately 16% of the attrition values were yes. Now on this slide, I'm just going to highlight a few box plots that I made as part of my exploratory data analysis. On the far left side of the slide, we're looking at a job satisfaction versus attrition box plot. And the key takeaway from this is that lower job satisfaction scores are more likely to have a value of yes for attrition than those with higher job satisfaction scores. In the middle box plot, we're looking at monthly income versus attrition, and the key takeaway from this is that the lower your monthly income, the more likely your attrition value is going to be yes. And then on the right hand side, we're looking at age distribution by attrition, and the key takeaway from here is that those who are younger are more likely to have attrition values of yes than those who are older. And now I'm going to clarify whether or not I use supervised or unsupervised learning methods. For clarification, I trained and tested on 4 different supervised machine learning methods. I tested on a logistic regression, which I scaled variables for this. I tested and trained on a random forest, a gradient boost or XGBoost model, and a random forest plus SMOTE model. And SMOTE stands for synthetic minority oversampling technique, and this technique is used to balance classes. A brief conceptual introduction to the models. A logistic regression is essentially a linear model that predicts probabilities of binary outcomes using a weighted sum of inputs. A random forest model is an ensemble of decision trees that votes on the final prediction. An XGBoost or gradient boost model is a boosting algorithm that builds trees sequentially to correct prior errors. And a random forest plus SMOTE model combines XGBoost with synthetic oversampling to balance classes before training. I'm going to highlight the training test split, the random seed, and how I found my optimal models. On each of the models, I used 80% of the data set for training, and I used 20% for testing. The random seed that I used for reproducible results was my M number, and that's 101,193,71. And to find the optimal models, I created a parameter grid comprised of at least a couple values for each of the parameters. I then used a grid search CV using ROC-AUC, and then I fit the training data to the grid search and extracted the parameters of the best model. Now I'm going to highlight the feature importance from each of the models. For clarification, these are normalized gain values, and gain focuses on how much each feature improves the model. So on the top left-hand side, we're looking at the logistic regression feature importance scores. Overtime was the most important feature within that model, and then business travel frequently was the second most important. So those who travel frequently for business related reasons. On the top right hand portion of the slide, we're looking at the random forest feature importance scores. The first variable, or the most important variable, was monthly income, and then overtime. And then for the bottom left hand side of the slide, we can see gradient boost importance scores. The most important variable was overtime, and then the second most important was job level. And then the bottom right of the slide, we're looking at the random forest and smote feature importance scores. So the most important feature in this model was stock option level, and then the second most important was job level. So there are differences and similarities between each of the models, but a couple of the variables that showed up in multiple of the models was overtime and job level. And yeah, that's it for this slide. On this slide, I'm going to highlight the performance on each of the models in the training data set. So the precision, recall, and F1 metrics below are specifically for the cases where an employee left the company or the attrition value was yes, because that's pertinent to the goal of the project, which I'll rehash later. So the first model, logistic regression, had the lowest precision, recall, and F1 scores, as well as the lowest ROC-AUC score of 0.86 or 86%. And then random forest and gradient boost had extremely high precision, recall, and F1 scores, as well as an extremely high ROC-AUC score ranging from 0.99 to 1.00. And then the last model was the smote plus random forest, and that had a precision of 0.82, a recall of 0.68, and an F1 score of 0.75. So it had a higher precision than the logistic regression, but lower recall and F1 score. And then its ROC-AUC score was 0.96, which also was higher than the logistic regression model. And yeah, that's it for the training performance metrics. Now we're going to look at the testing performance metrics. The first model, logistic regression, had the lowest precision, but it had the highest recall and F1 scores, and it was tied for the highest ROC-AUC score. The random forest, the second model listed in the table, had the highest precision, but then it had the lowest recall and F1 scores, and it was tied for the highest ROC-AUC scores. And then the gradient boost in the smote plus random forest models, those had the lowest ROC-AUC scores. Their F1 recall and precision scores were somewhere between that of the logistic regression and the random forest models. Provided the performance metrics on the last two slides, I'm now going to give you a recommended model. In this case, the recommended model is logistic regression, and the rationale is that it has the best recall, or catches the most attrition cases. And when addressing recall, just as a reminder, it would help address the question of all the people who actually left, how many did we correctly predict would leave? In addition to this, it's worth noting that it was tied for the best ROC-AUC, so it's pretty effective at separating classes, especially relative to the other models that were built. And then just further emphasizing the importance of recall, provided the goal of the project is to build a model that identifies which employees are most likely to leave the company, the best recall in this case is very significant and crucial. And just as a friendly reminder, the project objective was to build a predictive classification model that identifies which employees are most likely to leave the company using demographic, job-related, and performance-related variables. And yeah, that's it for my presentation. Thank you very much for attending this, and have a great day.